Hello everybody, welcome to the fifth in the series of water quality webinars. My name's Gareth James Lloyd and I'm a senior advisor at the UNEP-DHI Partnership, where one of our focus areas is on water quality. I'm going to be the facilitator of the webinar today with technical support from Maya Bertule, also of the UNEP-DHI Partnership. If you'd like to learn more about who we are and what we do, please check out our website after this webinar. The main purpose of the series is to raise awareness of the importance of water quality and to introduce participants to the main challenges as well as ways in which these challenges can be addressed. The first webinar in the series presented global goals and some of the lessons learned in water quality with some different case stories. The second webinar went into a bit more detail on some of the key challenges in terms of the impact on water quality and human well-being and vice versa, as well as looking at water scarcity and climate change. The third webinar looked at how you need to develop and apply governance frameworks, as well as some of the issues you need to be aware of. The fourth webinar covered water quality interventions in terms of technical solutions, including management and modeling approaches. This fifth and penultimate webinar is all about water quality management and regulatory tools. And thanks to Maya, all of these webinars are going to be available online from our website. On the agenda today, we have Jesper Dannisøe, and Jesper is going to be talking about water quality regulation tools and different monitoring approaches. And we have as well Philipp Saile, who will be talking about monitoring water quality as part of the 2030 Development Agenda, which is of course part of the SDGs or Sustainable Development Goals, many of you have probably heard of. Each presentation is going to last, well, Jesper's will last probably about 20 minutes and Philipp's 10, and we'll take a break in between for 1 to 2 questions along the way. There should also be time to take in some additional questions at the end, and if you look at your control panel on the right of the screen in front of you, you should be able to see a box for submitting questions. So please feel free to make good use of that. If a small request, if you could keep your questions as short and concise as possible, that would be a big help to us in reading and responding to them. As mentioned, all of the webinars are going to be recorded and made publicly available. That will be both on our website and via YouTube, and they can also be accessed through our website at unepdhi.org. What I'll do now is I'll ask Maya to pass over the microphone to Jesper, who'll start his presentation. So over to you, Maya and Jesper. Thank you.
Well, hello everyone. Well, as Gareth just told you, we have been looking at water quality in many different aspects during these different events. And what I'm going to do today is to look a little into regulation tools and also to monitoring approaches. So let me get started. Let's see what we have here. Now, the problem is that first of all, we have to make sure what we are talking about when we talk about these different regulation things. And I have split them into 4 different things. Something about licensing, something but very short on financial instruments. Then of course we have the modeling, and finally monitoring. And if you look at the agenda today, you will see that we sort of take up on monitoring twice, both in this content and also in the SDG content. Let's start by the licensing. Licensing is in principle the backbone of controlling who is discharging what, where, and how much. And for most countries, you probably have the necessary legislation. That means that there is a legislation that takes all these different things into account, and those are often the tools that you as an operator or as an authority have to live up to. So in principle, if you have such legislation, if you don't have a license to discharge, well, in principle, you don't have the right to pollute. Now, I know that many countries, they are still in the approach of building up all these different things. So you may have a lot of already existing entities that are discharging without a license. But let's look into what can we actually do. Now, licensing tools, as I said, they should be something about knowing what does this happen, what happens to the water when we are discharging something. Because a licensing tool can be very, very academic, but it should be linked up to the real world. So when you give a license to somebody, you need to know something about what kind of organization is it, what kind of factory is it, and in many cases you would also have a legislation that may say something about the need for having an environmental impact assessment, an EIA, before you can actually give a license to operate. Most countries will also have a list of operating companies that need to go through an EIA. Then you have all those which you can in principle just give a license based on accepted knowledge about their discharge, and that would typically be small companies who are discharging something which is minimal, and you also know what is the contents. These are some of the existing, or in most countries existing industries that will have to have an EIA before you do anything about their discharge. Of course, power plants, nuclear power, hydropower, usually large-scale infrastructure systems that needs to have an EIA, so we know how much we are actually polluting and regulating possibilities in a license. Steel mills and iron mills are also very important, having a big impact on the environment. The chemical industry, and here I would say that most countries usually have something about a certain production volume, that if you are above that volume, you need an EIA. If you are below that volume, well, you can have an easier access to a license. It gives itself that if you are producing explosives, you probably very much like to know what is going on and making sure that the license you give is within certain safety limits. But some may also be a little bit surprised that actually something like highways or ports, terminals and airports will also need to have an EIA. In many places, an airport could be just something very small, but it could also be larger in international airports or national airports, which has to be extended. Maybe the airport has been there for many, many years, but it needs an extension, and then you should usually give it an EIA before you decide. And then waste disposal in different forms, incineration or landfill. And in some countries also, if you are putting up a wastewater treatment plant, even if it's publicly owned, it may also have to go through an EIA to make sure that you give it a license that is actually living up to what you want to do. Let's see if we can click to the next one. License structure. Well, the problem is that when you are going to give licenses, there is a lot you need to know locally, but there's also a lot that you can actually get on the internet. Because whenever you give a license, you need to know something about what is actually going to be produced, how much, how well is the production described, what kind of raw material is going into the system, what kind of raw material passes through the factory and ends up in the waste. You are not alone if you want to find out, because what you can do is in most cases you can actually find a lot of information about nearly any type of industry in the world if you go out to search for the net. And the next problem is, well, what kind of treatment and how can you actually handle such type of industries? Well, check out the word that I've written here, BAT, Best Available Technology. And I even put in a reference to a place on the EU website where you can learn about how to handle the different kind of industries, and you can just in the bottom see that there's something about the ceramic manufacturing industry, wastewater and waste gas treatment, and emissions from storage. But there's a long list if you go in on this one, and there you will get a lot of help for your daily work. So you in principle are not alone. Financial instruments, well, you can choose between these two. I think usually you can choose between the carrot or the stick or the whip. And that means that you should go into a discussion with industries, especially those industries that have already established themselves, but maybe they don't have a actual, what you can call it, operation license, and find out how can you work with this organization to reduce their impacts and hopefully help them to understand the practical thing in having a good license and also having legitimate ways of operating. Sometimes you can get them so to speak, by the nose by giving them some good opportunities with the carrot, but sometimes you may also have to take into consideration that your legislation may give you the access to actually use the whip or some kind of threats to make sure that they will actually do what they should do. It is difficult sometimes to make companies do something, but we may have some incentives to have them reduce the pollution. Some of the possibilities could be that you may, if your legislation allows it, you may actually give them maybe some tax reduction for a period of time if they invest in treatment or other facilities that will reduce the pollution, or you may give them some years to fulfill the license, maybe with some stepwise approaches where you say by year this you have to reach this level, by year that you have to reach the full level of reducing pollution. Another thing could also be that if you have a request from a company who wants to establish a new factory, maybe what you could do was to give them some demands living up to your national legislation, but maybe also handling them maybe some, or have access to giving them some cheaper federal land where they could build their factory, and by giving them this incentive, hoping that they are also willing to do their part of it, aka reducing the pollution. Now, in some of the previous webinars, we have discussed possibilities to use modeling to find out how can we actually use the model to help in finding out what are the impacts when we are discharging. And you have to remember that every time you give a license, you need to know what is upstream and what is downstream. So when you give a license and you give some quality levels they have to live up to in their discharge, that it actually matches up with what is up and downstream. So you look at all the different impacts to see whether you can actually find a level which can be used. I think I said in one of the previous webinars that there's a problem in working with standards, that everybody has to live up to the same standards, because if you're discharging to a very, very big river, then the standards may be fine, but if you're discharging to a small river, then standards may actually lead to the fact that you are more or less completely polluting the river that you're discharging into. The illustration is just to show you that if you use a model, you may sometimes be able to look at some depth profiles of a river and look at the impacts from a discharge from a given source. But we'll return a little bit more to the modeling, because when you have modeling, you should of course count all upstreams and downstream loads to find out how much are they actually discharging, and also find out what kind of discharges you may have, because they may not discharge the same. Some may discharge a lot of organic matter, some may discharge oil or other stuff that is not easily broken down in the system. So you have to know all that. And of course also find out whether all those upstreams and downstreams are in compliance with their permits and licenses, and if not, then you will also have to do something about them. And all of this you need to put into a model and calculate the effect of where to put a new discharge. But it is extremely important that the data you feed into any kind of model is actually as close to the real world as possible, because if you don't have that, then you in principle have something which does not give you a good tool, but gives you a lot of troublesome work. To do anything about licensing, it's also very important that there is some monitoring going on. Giving a license is certainly not the end of what you do with a company. It is the beginning of a long period of work together, where there must be a self-monitoring program given for the factory, which means that they have to look at what is it actually they are discharging. They have to look at maximum concentrations and what kind of license you have given them. Sometimes you may give them some maximum concentrations that may even be seasonal differences, that they may be able to discharge higher concentrations in the winter or in the summer. And then very importantly also give them some demands on the load, that means the flow times the concentration and time, to make sure that they do not just dilute themselves out of the problem. Because if there is a load concentration, that means so and so many kilos per day, it doesn't matter how many tons of extra water they add in, they would still have to live up to the discharge licensing control. Monitoring program One program which is given to the factory itself is called the self-control system, where they have to do constant monitoring, for instance, of the volumes they're discharging, and then maybe monthly or weekly or whatever you decide in terms of the water quality, where the focus is on those important water quality variables that have an impact on the environment. And the authorities also have to have a control system. That means that sometimes the authorities should also go out and take a sample from this factory to find out whether they are in compliance with their license. So it's not an easy one, but it is something that both parties can actually learn something from. So I think I'll stop here from the first part. I've also been given the possibility to talk more about monitoring and monitoring systems. So I'll take a short break here and ask if there are any questions to part number 1 and leave the word back to Gareth.
Many thanks for that, Jesper. I can see there's one question for you, and that is what can be done about existing polluters who don't have a license? Could you say a few words about that, please?
Yes, I think the important part is to take your legislation very seriously, and I'm sure that you have a legislation most places where there is a possibility to go in and reduce the discharge from certain factories, those who do not have in principle and license to discharge. Because if you can't do anything about that, then it is going to be very, very difficult to ask factory 1, who just happened to come after factory 2, that they have to live up to certain strict standards, while factory 1 is just discharging whatever they have without any kind of control. So look into your legislation and see if there are any tools available for such actions.
Thanks, Jesper. Before I ask you to move on, I'd just like to remind the participants about the question box. So if you have any questions to Jesper's part 1, please send them there, and we'll do our best to find some time at the end to address them. Please feel free to continue, Jesper.
Okay, I'll do that. Now the next part is how do you actually monitor point and non-point pollution, and it can be quite troublesome actually to do some of them, especially the non-point pollution. I'll try to give you some ideas. But in principle, we need to find out what is monitoring. This is from Robert Ward, who is a professor at the Colorado State University. He said that monitoring is an effort of the society to learn by some form of measurements about the chemical, physical, biological, and ecological characters and behavior of water in the environment. Saying that if we want to do a good monitoring, there's a lot of things we need to know to actually be able to move on. When we look at monitoring, it is part of a big system. It's not something that you do just by finding out now we're going to do it. It is a part of this sort of circle that we have. There's a policy, there's some strategies, legislation, planning, and then you have the monitoring to look at enforcement and compliance, which is part of the management, and then you get some data from your monitoring that you can in principle feed back to the policy level to find out whether you have to change your legislation, to change the way you do things and how you operate in the future. Now, principles for the monitoring, if we take it bit by bit, looks like this one, that there is a demand for data. There is a demand for setting up a monitoring strategy, and then you have to design a strategy or design a way to do this that actually lives up to delivering the data that you need. Then you have to have all the simple things, which is in principle to collect the samples, to analyze them, to handle the data, and do the reporting, and then use the information you get to feed back to this water management system. So you can say that this is sort of a sub-circle of the other one you just saw a minute ago. So the aims of doing this is, of course, that if you are the public, you would like to know, for instance, is the water that we use in the surface water, is that safe for drinking, or can we go swimming in it, or what about fishing and sporting? And if you are an industry, you would like to know that your permit or your license and the way you operate is actually justified in how you are discharging, and that you are living up to your expectations. And also that we need also to take into consideration that many places we now have the NGOs, and they are quite strict on seeing whether there's a compliance to the law from all the different type of dischargers. And please remember, a discharger could also be a public treatment plant or other public areas of discharge, which also have to live up to certain standard criteria. And finally, if you are an administrator, you would also know to where should you actually focus the management that you have. Is it important that you build up your monitoring systems? Is it important how you report and what you are actually doing in your monitoring system? Finally, legislators, they have put out a legislation, and they will probably also know if the money they put aside, for instance, for monitoring, is actually being spent on monitoring, and how are the results that they are actually spending on. Now, the aim of a monitoring is, of course, for these reasons, which I also mentioned briefly in my first presentation, that there has to be something about whether the license or permits, they are in compliance with the law. And we also need it because if we do not do good monitoring, it's very difficult also to try to trace what we call the non-point pollution. In principle, non-point pollution is a pollution you cannot tie to a specific discharge point, a specific pipe, or something like that. And then, of course, we want, as monitoring devices or monitoring authorities, to know what is actually the water quality in the water bodies we are working with, because when the next one comes to ask for a license, we need to know what is actually the capability of the water system to accept or to be able to handle the new discharge. And of course, monitoring is very often integrated in your legislation, so you also have to make sure that there is a justice for what you are doing. When we talk about monitoring, in principle, there are two major ways of doing it, either the short or the long-term monitoring. And the duration of how long time you would actually run a monitoring system. So in principle, we talk about these short terms, and those would very often be that you need to get specific information about a specific situation. So you may set up a short-time monitoring system where you may only be sampling for maybe a couple of weeks or a couple of months. Then you get some information, and then you in principle do not continue the monitoring. Short-term monitoring often demands that you have very intensive sampling. That means that you may sample every week, every second day, or even every hour if you need to do that. But if we look at long-term monitoring, which most of you are probably working with, then we are talking about monitoring systems that in principle would work for years. And of course, every year when we get monitoring results back, we may have to change the way we do the monitoring, but the principle is that we want to know something about the water body from now and in all, let's say, administrative future, so we know what we're talking about. Now, if your river system looks like this one, it may be quite difficult to find out where to put your monitoring stations. In the ideal world, there would be no limits to how much money you have and how many resources you have to build up a monitoring system. But in the real world where all of us are living right now, there is probably a strict regulation to say how much you can actually spend. So if you have a system like this one where you have some cities and you have some agriculture, mines, mining industries and other industries, it's quite difficult to find out where to put your monitoring stations. So you also need to look at what are you using the water for in each of the rivers. For instance, if you are using water from this river system, this part up here, you're using that for drinking water, you need to put up monitoring stations that gives you information about the water quality before you actually clean the water and pipe it up to your citizens. If you have large areas of agriculture, then you would also like to know where does excess, for instance, phosphorus and nitrogen come from, where does certain kind of pesticides come from. So building a monitoring system is certainly not easy, and it is something that has to be done step by step when you know exactly what you have and what kind of upstream discharges you have in your system. Point source pollution in principle are easy to find because, as they say, it is a point, and if you can identify the point, then you could go in and start taking some samples there and find out what is actually the load, what is the concentration, what is the flow, and how much is actually being discharged per year from this point. And then you can go upstream in your source to find out where is all the load coming from. Is it coming from one factory? Is it coming from several factories, suburbs, treatment plants, overland, overflow, or something like that? You have to then spend a substantial part of time to find out where are each of the sub-sources that you have. But usually it will be easy to make a description of where is it actually, because you will usually be able to describe what is the size of the catchment where all this is coming from. So you have to do some work on the upstream part of your pipe. Now the non-point is much more difficult, because what is it actually? It's not a place where we can go in and measure. So sometimes we have to make an assessment of how much are we actually getting. Where does it come from? How often does it come? How big is it? Difficult and certainly not easy, and very often the only thing we can do is to try to work with it indirectly. So that means that if we have a river here, if you look at the blue one, the blue box with this way going from left to right, you know where you have your point sources. You know also where you have your water quality monitoring stations on the river. So if you know what comes in on the top of this section you are monitoring, and if you know what goes out in the bottom of your section at water quality monitoring station number 2, you know what the point sources are, point source 1 and point source 2. Then if you take the values, then you can subtract the different loads that you have, and what you are left with is in principle the non-point load. You also have to remember that the non-point load may be bigger than what you see at the water quality station number 2, because depending on the distance, the river is capable of doing something about some of the discharge that you put into it. So you are at least in a better shape to find out how much is the non-point load and how big is it. And if you use GIS systems, you can then use this section of the river to find out what is the actual land behind area, and maybe go down to analyze how much is aquaculture, how much is urban, how much is streets, and so on and so forth. And by doing that, just like you did with the point sources, you try to dig in to quantify each of the sources that are actually part of this non-point load. And to the extent possible, you have to find out if you can actually segregate the non-points, so you actually end up by having some real point sources that you can't measure, and by doing that, having a much better overview of how is your monitoring system going to answer questions like the water quality conditions in your river. And you will have also a database on all the different sources that you have in your river. Try to quantify them, try to find the reason, look for this, as I said, to see whether you have some subsources where you could put in some treatment, maybe simple root zone treatment system for agriculture or for village sewage, and you'll be much better off to know about your water quality in your main river. Now, these were the words from this section today. So any questions, you're welcome.
Thanks, Jesper. Yeah, people are making excellent use of the questions box now. One question we have here is how can NGOs be part of a monitoring process?
Well, NGOs can actually do a lot, because they can help in tracing the different kind of both the point pollution, where there may not be information about who's actually at the end of the point, and they can also help in assessing the non-point pollution by their local knowledge. If they know where there's a village, they can see, is there actually a ditch or something like that leading from this village to the river or to the lake, and if not, then it probably must be something about some non-points. So by doing that, they can actually help a lot in mapping out where do we have the sources, how many of these sources are non-point, and how many of these sources are point sources.
Many thanks for that. One more question before we move on. I'll save a couple till the end, but could you say a few words, please, about the differences in monitoring between the developed and the developing world?
Oh, that's a difficult one, because you would also in the developed world find countries that are very bad in doing a good monitoring. But I think the important thing is to use the resources you have optimally and make sure that whenever you establish a monitoring station, you don't just establish it, you make a good design and find out what is it you want to measure, how often do you want to measure, and what will you use the results for? Because if you do a lot of monitoring and you don't use the results for anything just because somebody told you to monitor, then you are wasting time. That happens in developed and undeveloped countries, and I have fortunately also seen very, very good programs in some of the developing countries where they could see now we have to do something. They put up some very good designs for their monitoring networks. Gareth, back to you.
Yeah, thanks, Jesper. I guess available resources also play a key role in deciding what to do and how. And I know that Philipp will be saying a few words about that in relation to the Sustainable Development Goals and water quality. So without further ado, I will ask Maya to transfer the presentation over to Philipp. And Philipp, whenever you're ready. Yeah, we can see your, yeah, you're almost there. So if you can unmute your mic and start whenever you like. Thanks.
Okay, hi Gareth. Thank you very much for introducing. Following Jesper's presentation, specifically on the monitoring, I would like now to give you a short overview about the ongoing activities in terms of the monitoring of water quality in the 2030 development agenda and specifically the Sustainable Development Goals. And I would like to start off where the first webinar with Joachim Harlin's video interview and Peter Kofert's presentation on the water quality in the context of the SDGs stopped, and go a little bit more into detail on the specific target 6.3 that tackles the issue of improving water quality. So just for a short repetition, in the SDG goal number 6, it is about ensuring access to water and sanitation for all. And there are 6 technical targets and 2 targets about the means of implementation. And target 6.3 is one of these technical targets. And over the last 2 years, technical task teams have worked on developing specific indicators to report on progress in terms of these targets. And for target 6.3, there are actually now 2 indicators that are being discussed and at the moment are being worked on. One is on wastewater, and this is about the percentage of wastewater that is safely treated. So that would be the indicator regarding the sources of pollution, a specific source of pollution. And then there's a second indicator, which is the percentage of water bodies with good ambient water quality, which is more the effect-oriented indicator in that context. And by combining these 2, the international community is hoping to establish and assessing more clearly the effects of sources and effects in terms of water quality in water resources. So when it comes to developing a global ambient water quality indicator, we started off with the previous work that has been done in the UNEP-DHI water program, where a global water quality indicator had been developed in the past. And that indicator is based on a composite index, actually, that's a so-called proximity to target index that compares certain parameters, certain water quality parameters to defined target or also standard guidelines benchmark values that are defined in a certain context. These benchmark and target values are often defined at the national context within in standards, but increasingly more often also on the river basin scale or on the regional scale, such as in the Water Framework Directive. Throughout that development process, there were a lot of discussions on which parameters to include in the development of that indicator, and there is a compromise among the coverage of indicators and the pollution sources. And the current approach looks at 5 parameters to be included in the final indicator, and you can see them on the right. One is the TDS, the total dissolved solid, that signifies nutrient pollutions and salinization as a proxy, as a coarse proxy. The second one is dissolved oxygen or oxygen saturation in water bodies, and additionally there are two more nutrient pollution related water quality parameters, which are inorganic nitrogen and inorganic phosphorus. And last but not least, a very important one to also include microbial pollution and include effects on human health are E. coli or fecal coliform bacteria counts. That indicator, as it is defined right now, is consisting of a process to actually use the concentration monitoring values for these selected parameters, which are then temporarily aggregated. And after this temporal aggregation, there is the calculation of these so-called proximity to target values, which are more or less the difference between the average, the temporally aggregated concentration values towards the targets, and ultimately these monitoring data and the PTT scores that are calculated for single monitoring stations, they are spatially aggregated on the reporting scales. In the past, the spatial aggregation has been done irrespective of any hydrological aspects. So a country index has been just the calculated from all the stations within the country. And for the future, we are looking at taking some of the aspects of the Water Framework Directive into account, which is having a more catchment and river basin specific orientation. So to actually first calculate these indicators on the river basin and then aggregate it to the country. The Sustainable Development Goals are supposed to be universal for all countries, which means any country in the world, irrespective of its capacity, shall be able to participate in the development agenda and also be able to participate in the reporting and monitoring framework. So the idea is actually to, or what we have proposed is a so-called monitoring ladder that allows for a stepwise increase in the complexity of monitoring in terms of different aspects. And with respect to the water quality indicator, two very important aspects are actually the number of parameters that are included in the indicator calculation, and the other one is, and this is what Jesper was just talking about, also the density and the typology of the existing monitoring networks in the countries. So at the moment we're thinking of starting at a basic system with these proposed 5 parameters and use the existing monitoring networks in the countries, and then stepwise increase and include additional parameters to adapt also to local conditions regionally or in the countries, and promote the increase of monitoring network coverage in the countries. And the idea is to finally move to a very comprehensive set of indicators and a comprehensive coverage in terms of the monitoring towards the end of the 2030 agenda. And on the right side here, you see a list of examples of additional indicators, and a lot of feedback that we got from the countries is that actually the local guidelines, the local national standards and requirements and also capacities need to be taken into account. So you have on the one hand developing countries that at the moment do not have the required capacity to monitor a broad set of indicators. On the other hand, you do have more developed countries, already existing regional frameworks like the Water Framework Directive, where a broad set of indicators is already being monitored and analyzed and assessed. In terms then of the national monitoring and reporting requirements for the countries, the current framework foresees a so-called baseline assessment that shall be conducted over the next 2.5 years. And by the end of 2017, we need to provide a global baseline assessment, and in that process, the countries will be required to develop and report on the indicators. And within that process, they will be required to designate the water bodies they will actually be reporting on, and also the river basins. And on the right side here, you can see an example from the Water Framework Directive, where some of the ideas we're using for that global indicator are also drawn from. The Water Framework Directive is much more complicated in its approach, and we need to keep it much more simple to actually maintain the universal approach and not to include all countries. But we draw from the ideas that the countries will need to identify and adapt the monitoring framework actually to their national conditions. And once they have defined the water bodies and river basins they will be reporting on, and also the parameters that they will be reporting on, then they conduct a classification based on the existing monitoring data. And for the future, we hope that stepwise, according to the monitoring ladder approach, countries that are not yet in the position to actually cover a broad range of indicators and a broad spatial and temporal coverage will stepwise be able to increase their reporting capacities. However, there are a lot of challenges that we are facing at the moment. One is the definition and also the designation of water bodies and river basins. There are a lot of experiences that we learned in the Water Framework Directive. At the moment, many countries have quite different views on how to determine what a water body is and where the borders between different water bodies. Other issues and challenges arise from the definition of benchmark values. In the past, we have used a global set of benchmark values from the World WHO drinking water guidelines. A lot of countries have their own benchmark values, so at the moment we are in a process to harmonize these ones, and for the global monitoring, recommend certain values to enable countries to report on them. Furthermore, it is open, and we're discussing which classification levels we will actually be using. So the indicator actually requires or target requires, the indicator requires a good ambient water quality, but the question is what is good, and how do you differentiate good from the other levels? And last but not, or one major issue about harmonizing that indicator are the large differences in the monitoring systems, both in terms of the spatial and temporal coverage. There are operational systems in place in many countries, but they have a very different orientation in terms of spatial and temporal applicability, and in every country they are aligned to different societal values and uses. So we try to come up with an approach that is irrespective of the actual use of the water bodies to be able to compare them globally. One very interesting approach that we are currently looking at is also to include additional data sources, such as from remote sensing, satellite, or airborne, includes the results of modeling, and increasingly also citizen science, especially to cover areas where there's at the moment a little monitoring being done and which are very data scarce. So this is it from my side. If you have any questions, please go ahead.
Many thanks, Philipp. That was not only very interesting, but also looks quite challenging. And we have some good questions here, so I hope the participants can bear with us for a couple of minutes, because they might find this interesting. Question one to you is how will countries cope with all this monitoring requirements for the indicator, particularly in terms of the level of complexity and the probable expense?
Yeah. So with that universal approach, we are looking at really countries with totally different capacity in terms of the monitoring, as you said. So at the top notch, you have really highly developed countries with harmonized monitoring systems. We have learned a lot from the Water Framework Directive, and there were hard lessons to learn. So there are regions where you have a good alignment, but for I would say, the majority of countries, the burden of reporting might be quite high, and there needs definitely to be a lot of capacity development being done in that regards. And we are currently also preparing targeted capacity development activities on the technical level to enable countries to improve their monitoring capacities in water quality. But in terms of the resources, we will definitely require additional funding, probably quite large-scale funding from international donors. And this is one of the key issues probably in the entire SDG monitoring discussion, because it remains to be open which organizations to which detail will support various countries in their reporting capacities.
So it's scalable. It's a scalable approach. There's help on the way, but there are also some recognized funding gaps, at least for the moment, that need to be addressed, and those are quite serious. Thanks. Another question, Philipp. Why are there no biological indicators included in the ambient water quality indicator?
There's a good reason to actually use biological biota indicators, and there have been a lot of successful systems assessments using these ones, predominantly the Water Framework Directive, the EPA Clean Water Act. The problem is, on a global scale, these biota indicators, they are not aligned, not harmonized, and many countries are not, at least yet, in the position to use them directly. I wouldn't exclude it entirely that at one point these or additional biota indicators might be included in the approach, but in order not to lose the less developed or the regions that are having lower capacities in terms of biota monitoring, the decision was made actually to start with the, I would say, more classical approach of using physical chemical parameters in the first place.
Thank you. Another question we have is, are there successful examples of the journey up this monitoring ladder? Could you say a few words about that, Philipp?
Examples on which scale? Yes, they are. One good example is the Brazilian Water Authority, who has been created at the national level only 10 years ago, and they have gone a long way in a rather short time frame in starting from quite basic information that has been spread all over the country in collecting and extending the regional monitoring networks and aligning these ones at the national scale. So that's one quite good example other countries might also have a look at.
Yeah, thanks. I think in terms of the specific example you presented, I think I'm right in saying that it will also be piloted with countries and modified also based on the inputs that are received from countries in the coming months. Is that right?
Correctly. So at the global level, currently there's a group of UN agencies working on harmonizing a comprehensive, consistent global water resources monitoring framework, which is called the Global Expanded Monitoring Initiative. And in that approach, in working towards a global baseline assessment by the end of 2017, in next year, in this first half of 2016, a set of pilot countries will be visited, and all these, not only for the water quality indicator, but for all indicators that have been developed, they will be tested within the countries, and the methodologies will be reworked and redesigned. So that's a constant process, and we expect that while on the one hand we want to have a consistent indicator over time, we definitely are aware that these ones probably will need to be adapted to new technological developments, to increasing capacities in the countries.
Yes, thanks for that, Philip. Good answer. The last question goes to you, Jesper, so please unmute your mic. Those of you who've asked more questions, we've simply run out of time, but Jesper, which tools can be used for finding potential non-point pollution?
Yeah. As I mentioned in my presentation, I think one of the very good tools that you have available is actually to use GIS information and satellite images, because from those ones you can actually zoom in on areas and find out what is actually going on in those areas. And if you compare the information you can sort of subtract by just looking at the GIS information and your knowledge about your point sources, then you would actually have quite a good tool to go further into assessing what is the impact from the non-point. And if you search on the internet, you can find a lot of information about the typical load from, example, 1 hectare of agriculture, 1 hectare of pastry land, and so on and so forth. So you can actually, husbandry land, so you can actually go in and get some quite good information that you can use as starters, and then in the end, like all of us, we have to go out in the field to find out what is actually going on.
Thanks for that elaboration, Jesper. As mentioned, I'm sorry, but that's all we've got time for right now. But if you have any burning issues or questions, please send an email to Maya at the web address here on the screen in front of you, and she will try to get back to you. We're always looking to improve the quality of work, so we'd be grateful if we could use a couple of minutes to fill in the feedback survey, which you'll be receiving shortly. The 6th and final webinar in this series on water quality is going to take place on November 25th. The headline topic for that is data and knowledge management for water quality. And as usual, we've got limited space, so please feel free to book your space right now by following that link, which is also available from our website. Please allow me to conclude by thanking both you, the participants, and the presenters for taking the time to join us. We wish you all a very good morning, afternoon, or evening. Thank you.